Yeah, please wait. There will begin soon. Started. Started. Welcome everyone to Hello and welcome everyone to all the respected faculty members. A very warm welcome to this online FTP, which is organized by SSC NASCOM and sponsored by AICTE. The topic for this FTP is Digital Application Fundamentals, and we will be running this batch from 19 January, that is today, to 24th January. It's a 6-day online FTP, and we have curated a very good set of resource people to join this batch and take lessons, take classes for all of us. And I'm joined by my colleague Ranu Singh Chauhan. She will be working with you on any help desk related problems if you face any problems like that.
Good evening.
It's echoing. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just waiting for the network to settle. So we are just w waiting Luthra to join us. He is director at AICT, and he has very kindly consented to deliver the inaugural address. So just we are waiting for him to join this. I think he might be. Let me see. Patience. Wait. Control C. Sunil.
इसलिए रिस्ट्रिक्शन ऑन क्रिएशन ऑफ लेवल्स को रिस्ट्रिक्शन दिया 100% का नहीं प्राइमरी में 600 का बोल रहा है
I will just call him. He may be joining. Welcome, sir. Welcome. So nice to see you here.
Thank you, ma'am.
So I'll just introduce you, sir. 1 second. I'm just. So I'm very happy to share that Dr. Sunil Luthra has joined us. And at the very outset, I would like to thank AICT for giving SSC NASCOM the opportunity to host and organize this online FTP. And it's a privilege for me to be the coordinator for this program and an honor for me to introduce sir. My name is Kamna Jain. I work with SSC NASCOM. And uh, eh, just a brief introduction to Sir. Dr. Sunil Luthra is working as the Director, All India Council for Technical Education, New Delhi. Prior to this, he worked as the Director, Principal at Chaudhry Ranbir Singh State Institute of Engineering and Technology, Jhajjar, Haryana. He is also visiting professor Supply Chain Improvement, University of Derby, United Kingdom. He worked as Honorary Research Fellow at Triple Crowned Bradford School of Management, University of Bradford, UK. He has contributed over 300 research papers in international, referred, and national journals. Needless to say, he has an excellent research track record, more than 220 high impact factor papers in the international journals, and he has received more than 31,500 citations on Google Scholar. His H index is 95 on Google Scholar. He has received many awards and honors for the research and teaching. He acted as the guest editor of many reputed journals such as Journal of Cleaner Production, Technology Forecasting, Social Change, etc., etc. He has also published 6 books with reputed publishers such as CRC Press, Taylor and Francis Group, and New Age International Publishers. His research interests are production and operations management, sustainable production, and consumption. So it is my pleasure to welcome Dr. Sunil Luthra for his inaugural address. And once again, a very big thank you to AICT for giving us this opportunity to host this and organize the online FTP. Over to you, sir.
Thank you, ma'am. Thank you very much, ma'am. So, very good evening to all. Distinguished representative from NESCOM, Sector Skill Council, IT Sector Skill Councils, esteemed resource persons, and my dear faculty colleagues, dear participants, ladies and gentlemen. Once again, very good evening to everyone. It's really pleasure to talk this gathering on the occasion of this. Am I audible?
Yes, sir, you are very audible.
Yeah.
Clear.
Inaugural session of 6-day online FDP program on digital application in STEM. First of all, I congratulate NASCOM, ITES Skill Sector Council for designing this program because this is timely, relevant, and strategically aligned with national education reforms, industry expectation, and most importantly, future skill requirement. You know, uh, most of the faculty members or participants know about Atal Academy. Atal Academy means AICT Training and Learning Academy, where our central belief is very clear because faculty empowerment is the foundation of today's educational transformation. In today's rapidly evolving technological landscape, the role of institutions going far beyond the curriculum delivery. Now, not only curriculum delivery is important, but its quality and relevance in technical education is mainly capability building, confidence, and continuously upskilling of faculty members. Because institutions cannot transform themselves automatically, our faculty members, our educators drive this transformation, and empowering of this faculty member is very, very important. And this empowered faculty members and empowered educators will build future ready institutions, which is current requirement. So why this is very, as I told you, this is very timely faculty development program. Why digital application in STEM? Why? Because we are living in this era, which is defined by, you can say, digital era or digital acceleration, where lot of technologies, AI, data analytics, cloud computing, simulation tools, cyber physical systems are actually no longer our optional enhancement. Whatever the your branch or whatever the, you cannot escape from these keywords, these emerging areas. You have to, if you have to survive, then we need to aware about these emerging areas. So these keywords become core driver of scientific discovery, engineering design, and technological innovation. In, if I would say, STEM discipline, digital applications are redefining how these problems are conceptualized, how these systems are modeled and optimized, how solutions are scaled for real world impact. STEM education today must move beyond knowledge transmission to digital competence, analytical thinking, and innovation capability. This FDP program, Faculty Development Program, is strong or meaningful collaboration between AICT, Atal Academy, and NESCOM IT Sector Skill Council. Atal Academy focus on strengthening pedagogies and research orientation and academic leadership. While NESCOM bringing in this FDP, industrial relevance, skill framework, and alignment with emerging job roles. So this will help, definitely help. This collaboration will help and ensure that STEM education will be industry aligned, application oriented, and future focused. So most importantly, nowadays teacher role is completely changing. Teacher role is most significant shift in higher education, as I see today, is transition from this content centric teaching to capability centric learning. This Now this role of the teacher is changing, because whatever you was giving content, that is totally changing. Everything is available on this YouTube and this digital platforms. So as a teacher, if I need to upgrade myself, then something, what this FD after this FDP, what I should learn, digital application in STEM must enable outcome based and experiential learning. Then it will help to solve this interdisciplinary problem solving. Then most importantly, project driven and industry linked education. And finally, I will say continuous upskilling and reskilling is required because one in one survey I just in one survey I studied one survey where it says that the students in school students are not students in school are will not do job or this kind of job what we are doing today, or we are saying that this in this technological world jobs para is also changing. That's why continuous upskilling, reskilling is required. Another survey, a person normally in his or her career, normally they reskill themselves three to four times. This is one of the another survey. This as I coming back to faculty members are no longer just instructors. They are learning designers, they are mentors, they are innovation facilitators, and so I wish this FDP will empower educators to learn digital transformation with confidence rather than respond it too reactively. So in Atal, we strongly emphasize on ethical use of AI, data privacy and cybersecurity, inclusivity and accessibility in digital education, and sustainability of digital infrastructure. Technology must remain human-centric, ethical, and trustworthy. This is not merely technical requirement, but it's as a social obligation. So I wish this program will directly contribute to India's flagship national missions, Digital India, Skill India, Atmanirbhar Bharat, and Viksit Bharat at 2047. So I wish to all my participants this 6 day, my message is very simple and very clear. Engage deeply, learn with curiosity, experiment confidently with these digital tools. And most importantly, reflect on how you will transform your teaching, your research, your institutional practices after this 6 days. Let this program not be only just event, but turning point in your academic journey. So, I would like to conclude with a thought: the future of STEM does not belong to those who merely adopt technology, but those who will use it wisely, ethically, and purposefully. So I request all my colleagues, let's work together to build future ready institutions, digitally confident educators, skilled, innovative STEM professionals for India. With these words, I formally inaugurate this 6 day program on digital application in STEM and wish you great success and lasting impact. Thank you very much. Jai Hind, Jai Bharat.
Thank you so much. Thank you so much, Dr. Luthra, for that very inspiring address. As you rightly said, it is to empower the faculty so that they can reskill in today's evolving technology times, focus on how they can experiment and use these tools to modify and their working models, and how they can transform not just themselves but also the students, because that is what is going to lead to Viksit Bharat. And sir, I'd also like to share that we have the trainers also with us today, so they want to also say hello to you. So Dr.
Yeah,
Prakash
please,
Koteti
please.
Good evening.
from TechM is joining us, and Dr.
Dr. Sunil.
Gopal from he's ex Anna University. Dr. Gopal, if you can also come on camp and say hello to sir.
Sir, thank you very much for inaugurating this FDP today. From today, I have also joined Mahindra University, Hyderabad, Computer Science and AI. Thank you, and very happy to have interacted you on the first day in the new assignment.
Thank you, sir.
Thank you very much.
Great pleasure to meet you, sir.
Dr. Prakash Koteti.
Yeah, Very good evening, sir. Excellent inputs to all the participants to ensure that they pay attention to what is being covered in all these 6 days of program. Thank you so much.
And
Thank
Marcus has all the sessions with hands-on trainings, and he asks a lot of questions to the faculty to keep them engaged. So I think that keeps the faculty on, always alert to what is being taught. So
That's great, man.
right. So thank you so much, sir, for joining us. It is our indeed honor that you have inaugurated this, and that will ensure the success of this program. So thank you so much,
Thank
sir.
Okay.
Thank you.
Okay, thank you, sir. With this, we will commence our first lesson, which is the first topic is AI frameworks for developers, popular software tools and techniques for AI. And I'm very happy to welcome Dr. Surya Prakash Tete, who is a senior consultant with TechM, to take this session. A brief introduction to Sir is in order because at Tech Mahindra, Dr. Koteti focuses on infusing AI and agile methodologies into business processes to catalyze transformation and growth, which means that there are sophisticated learning solutions which contribute to national skill development initiatives, for which he leverages his expertise in AI, ML, and project management. Also, just one second. This winter in Delhi is giving me a lot of cough, so please excuse for
Yeah,
that.
it is a similar situation everywhere actually.
Yes, yes. And also, Dr. Guteti has a background as an assistant professor. So his lesson has a very robust academic foundation, which basically is going to help the mentoring and development program which he leads. Especially for this cohort, we are very happy to have him with us. So with that, I'll hand it over to you, Dr. Koteti, for your session. Thank you.
Thank you so much for this opportunity. So, good evening, all. First of all, let me wish you a very happy new year to each one of you. Uh, in this session, we'll
Yeah,
be
just
cover.
before you, thank you so much. Happy New Year to you also. And just before I go off camera, I'll urge all the faculty members to engage and interact. You can put your questions in the question box, and the more you interact, the more you will learn. Let it not be a one-sided conversation, and make use of this opportunity to learn from an industry expert so that you can enhance your knowledge and take that knowledge to your students also. With that, I will just go off camera.
Yeah, thanks. Let me share my screen. Yeah, hope I am audible, right? Let me just check chat simultaneously. Yeah, very good evening. Am I audible? Yeah, okay. So today's session will be predominantly focusing on artificial intelligence and machine learning, and particularly various tools, uh, including those, uh, especially in the context of processing voluminous data, right? So all these we'll touch upon, and you please ask me questions in between if you have any, right? Or you can type in the chat box as well. Right? So this is the agenda for today. One is introduction to AI, data science, and machine learning, and various architectures and components, in this domain, and then generative AI models in use cases like filmmaking, etc. And similarly, we look at generative AI in hospitality related things, right? So this is what we are going to discuss. So AI is a discipline focusing on creating machines that mimic human intelligence. So nowadays you must be hearing about things like reinforcement learning, right? So and agentic AI. So agentic AI has become more and more popular, considering the importance to various applications which are a kind of self-learning applications, right? So autonomous learning is something that is picking up momentum. So it is very important that how these tools and how these, let's say, algorithms evolve as a period of time, right from the 1950s, the concept of uh, machine learning and related stuff. It is not something new, right? It is very old concept, but we realized late because the realization in terms of business use cases, etc., that actually, realized in around 2005 and all that, right? Since then. So I have been working in this field last 10 years actually, because my actual PhD is on quantum physics 20 years back, which is something like, uh, it is a kind of complete theoretical models where, there was a situation where we used to think that will it come to reality, right? But now if you see, it has become a buzzword, right? Similarly, all these techniques and algorithms, they are very old, but how do we leverage now, considering the business impact is making them more prominent? So artificial intelligence, as I said, it is like, looking at certain techniques and tools that mimic human intelligence, and machine learning, which is a branch of AI, which is devoted to techniques that enable systems to learn from data, right? Now, since all of you are from academic fraternity, and I'm sure some of you will be publishing, right? So, can anyone type here most of the publications, if you see, right? What will be the uh, what will be main inferences and conclusions in the publications that you see in AML, deep learning, and all that? What kind of papers are being published? We industry, we don't give too much of importance to these kind of publications, right? So we build solutions. So that's why I'm asking. I read a lot of papers. So can anyone articulate what kind of papers? I will tell you. Most of the papers you see in general are improving a model and reporting a better accuracy or better confusion matrix compared to some other model. So there's very little that you see in terms of, but there are very good publications. I am not saying that, but predominantly, if you look at, right? So what I want all of you to take a pause and think through is, if you are reflecting on first principles, right? First principles, you can think of gradient descent, right? Is one of the technique, if you are familiar with it. And there are a lot of things, we have a lot of degrees of freedom to choose from, right? So that is something that we can focus on. That's what I just wanted to tell. Otherwise, it looks like, okay, these terms, terminology, we already know what is so special about it. So point I would like to bring here is that when you are looking at a particular discipline, these are disciplines, isn't it? And you need to focus on a particular domain. Like, for example, I don't want to be master in NLP. I don't want to be master in, computer vision, everything. It should be a particular domain. If you ask me, I work, uh, you know, specifically on medical imaging and computer vision related tasks. So similarly, you need to fix to a particular domain and try to work in that direction, right? Now after deep learning, you see generative AI. This has become a buzzword again because here we are talking about large language models, right? When you say large language model, predominantly we are saying that how do I interact with an abstract model, which is a complex, deep neural network, right? So all of you know neural networks. So let me explain all these concepts together with a simple example. Give me a minute. Let me know if you are able to see my screen. I will reshare. Yeah, can you see my blackboard? Yeah. So let me do it here. So first thing that you see here is machine learning, right? So on top of it, we have a that you must have seen that diagram, right? Then you have a deep learning and then generative AI and agents and all that, right? So fundamentally, what you are saying here is that if you take this machine learning, you define a model, something like y is equal to f of x, right? So essentially, what you do is you predict y given that f has a features like this xd. Assume that you have d features. You have d features, isn't it? So, so what you are trying to do here is depending upon y, whether it is a continuous or a discrete. If it is discrete, you call it as a classification task, and if it is continuous, you call it as regression task, right? So, so when you extend it further, like for example, to more complex problems, right? Where you have huge data set is available, complex data set is available with many features, and you try to come up with, you know, something called a neural network, right? So a neural network is conceptualized from human brain, right? Like the way we think, where our brain contains a whole bunch of neurons and which will trigger uh, thinking and decision making, right? So there you say that I have lot of features. So x1, x2, and so on, xd, where d is very large. And each of them, you put them under input layer, and then you have a mm, this is called a hidden layer. H1, you can keep it multiple hidden layers, right? So when you do that, finally you compute, if you have multi-class classification, let us say 4 classes, you get probability, right? Using something called softmax, right? So if you say that C1 probability is 0.1, C2 probability is 0.6, C3 probability is 0.15, C4 is 0.15. So you take a kind of argmax, right, over all these probabilities. C4, and that will give you class. So what exactly happened where you started with a simple model like of y is equal to f of x, the most familiar model. All of you know machine learning or no? Are you aware of machine learning models? Any one of you? Can let me check the chat box. No, no problem. So, okay, doesn't matter whether you know you don't know, it doesn't matter because I will explain anyway. So basically you will be constructing a mathematical model from the features. So when you say features, suppose you want to see that, let me give an example. When I say y is equal to, when I say y is equal to f of x1, x2 and xd, uh, you take an example, something like, you know, I want to classify whether a person is having a risk of diabetes or not. So I have weight, height, and 3 months average blood sugar level, what we call HB1AC, I think, right? Something like that. And you also have smoking, like that. These are called features, right? So using these features, essentially you try to predict, right? Using these features, whether the right, you predict whether the person is diabetic or not. 0 1 binary classification. That is a classification problem. Now, on the other hand, if you want to look at a regression problem, you can think of house price. This is a standard example, right? Prediction, where you have number of rooms and you have construction area, water facility, like this, right? And you try to figure out a floating point value. Again, this is also y is equal to f of x, but in this case, y is a continuous variable, not discrete. So it's very important to understand the difference between these two. These kind of tasks are classification tasks because you have a label already. Y is called your label. This is your feature vector. Now suppose if you have more number of features, right? Like this, x100, and lot of data, then these models of machine learning might not actually give you a robust uh, prediction mechanism, right? So now I have a question. Why it is so? Any answer? So it is because that data is too complex to handle by these simple models, right? Because only non-linearity, for example, if you have a logistic regression, right, where your equation is something like this, only non-linearity will be something like this. So if you have feature space across two features, it is easy to construct this kind of a decision board. If you have so many features, right, where your Z is becoming a hyperplane, then it uh, learn from tries to learn from those features which are not statistically significant, right? Now, on the other hand, if you look at the network like this, you have the option to activate these neurons at wish. So here what we have, you also introduce a switch that is called a dropout. That means some of the neurons, if you wish, you want to switch them off, right? Because this is whole bunch of neurons connected with each of these layers, right? And multiple layers we have like this. So, right? So that means essentially when you look at a particular element here, each particular element, you can model this as, if you look at a free body diagram of this neuron, in the left hand side you have a summation, right hand side you have a nonlinear function. Summation includes, let me take two neurons, x1 and x2, and these are connected with this. So you have weight here w1, w2, and you say here w1 x1 plus w2 x2. You introduce some bias here, w naught. Okay. The reason we introduce is because you don't want to the function to vanish if these values are 0, right? So this equation becomes 1 by 1 plus e power minus of this whole thing, right? Now assume that you have so many such features, right? You try to get a fitting line, which is something like this, right? Suppose you have it, let's say three features, three-dimensional room. Suppose if you take like this. Now, how this look like? This look like this. You can think of a mat, right? You are putting from one diagonal to other diagonal of the wall. So this is your feature space. Now, if you increase number of features further, then it becomes more complex, right? Hence, you try to deal with more complex feature space using very straightforward mathematical function, which is not very effective. That is the reason when you come to this neural network, each node is a nonlinear function, isn't it? And these outputs are becoming input to next layer. So essentially, you develop a highly complex nonlinear function with lot of degrees of freedom to choose from, including number of layers that you want to have and depth of each layer and switching mechanism, a whole bunch of things. So this is what you need to understand. When we traverse from uh, machine learning to deep learning, why it's called deep, right? And after that, let me just share the slide again. And it is also important, just a minute. It is also important to understand what kind of data that we are dealing with, isn't it? You deal with structured data, semi-structured data, unstructured data, right? So, can you give me an example of what do you mean by structured data, unstructured data, semi-structured data? You can put in the chat box. Do you know? You don't know about definitions of structured, semi-structured, unstructured. So when you think of when you think of data which is having a schema, something like, uh, you have columns, each column is associated with a data type and set of values that it can take, right? So we call them as constraints, domain constraints, integrity constraints, and things like that, right? So that uh, luxury you have in the case of structured data, whereas semi-structured data is something like a JSON file or XML file, etc. Then you need to do a lot of work to make it some kind of structure around it. Semi-structured data might not have type information, but it might have to some extent schema conformance, uh, schema conformance, right? In the case of unstructured data, it neither has schema conformance nor the type information available, right? So, so that's why it is important to understand what type of data you have. So suppose uh, I am a as a researcher, right? What how do I look at what are the domains that you should have? You, as I said in the very beginning, it is not necessary that one should master all the domains, right? These are the various domains. What are the domains that we are talking here? We are talking here about machine learning, natural language processing. Within natural language processing, you have a classification. Sorry, you have something like information extraction, and you have a clustering of documents, right? And things like that. Now, on the other hand, if you work on expert systems or speech, you have a translators, speech to text, text to speech, so on and so forth. And then you have a robotics and then vision models, right? These vision models are something like image recognition and machine vision and things like that, right? Now, broadly, if you look at ML itself, it has multiple workloads. These are supervised learning, unsupervised learning, and you have reinforcement learning, right? So supervised learning, as I said earlier, you deal with two types of tasks. These tasks are for labeled data. One is classification, other one is regression type of task. And in unsupervised learning, you have clustering, association rule mining, and feature exploration, right? So I don't want to delve into all the details. So next, we have reinforcement learning where you have an agent. This agent is learns from environment itself, right? So agent takes action and it moves from one configuration to another configuration. As a result, you either attach a reward or penalty, right? That's how it is. So now, if you look at overall ecosystem of AMLDS, we are talking about simulation of human brain. There are two types of AI we have. One is strong A and weak A, right? So for all the applications that we are seeing, they are weak A, right? So we are aspiring to develop applications in the category of strong AI, but it takes little bit more time. So on the other hand, data science, you will be extracting data from various data sources. Data extraction is the key thing here, right? And you want to analyze the data and to get meaningful insights. So storytelling is one of the critical skills uh, for data analyst, right? If you are thinking of roles, you see there are a lot of roles that are there. These are like you can think of if you want to get into the very beginner level, like fresher, right? You can think of prompt engineer. Then you have ML engineer, data engineer, NLP engineer. That's how it is. So in this discipline, you can start your journey. It as simple as prompt engineering kind of role, right? Prompt engineering means that how do you interact with large language model? What kind of prompts that you give? They come under prompt engineering, right? So there are a lot of techniques like one shot, few shot, and chain of thoughts and all that. But we will see when we get time, we will discuss those things. So these are the few things that one will be required: mathematics, domain knowledge, storytelling, data visualization, and machine learning models. If one develop skills in among these buckets, right? Depending upon the overlap areas, you will be able to fulfill one of the roles. That's how it is, right? All right. So how this whole thing works, right? And what kind of tools that we'll be using it. So you first start with a business problem or a kind of a research goal, and then you try to come up with a charter with milestones expected and all that. Then you capture the data. The data can be captured through either internal sources or external sources, and then you prepare the data because this data is coming from external sources. We may not have control on quality of the data. That's why you perform various tasks such as data cleansing, data transformation, data aggregation, and things like that. uh, you understand these terms, or you want me to explain this? What is data transformation? What is data cleansing? You want to know those thing details? How to perform, etc. Or you're well versed with this? Okay, little details. So what happens is when you get this data, right? Your data ingestion can happen from various data sources, right? On which you may not have any control. So sometimes you will see missing values in the some of the fields. Let's say I have a data set where I have a column. In that column, 80% of data is missing. In that column, 80% of the data is missing. Now we know that we will use some imputation techniques like you fill the missing values with mean value of that column, correct? Or median of that column. Do you think it is advisable in this scenario to fill that column missing values with the mean or median? Assuming 80% of the values are missing, what will be the right option? You drop that column, you drop that feature, right? Because it doesn't contribute much, very little information. Now let me ask you one more question. Suppose I have 500 features. Now the standard deviation of 100 features is less than 1%. The standard deviation is less than 1%. What is standard deviation? Remember, this course is about AI tools and techniques and all that, right? So mathematical tools also tools. Tools not necessarily software tools, right? So let me explain you this. Let me share the board. Let me know if you're able to see my board. So I have features. Let's say I have 100 features. Out of them, what I will do is I will just write a for loop. Let us say for feature in data frame dot columns if data frame of feature dot standard deviation is less than 0.001, I will add this feature to my to be dropped list. To be dropped dot append current feature. So initially I define an array null. I keep adding this. Now suppose if I print at the end, you have list of features which are having standard deviation of less than 1%. What does it mean? What does standard deviation measure? It measures the spread in the data, right? Suppose you have a data distribution like this for a feature X. Now you can create slices in units of sigma, 1 sigma, this 1 sigma, this 2 sigma, this 3 sigma, like that, right? Now assume that I have another distribution which is like this. Now this has more spread. So this will be sigma 1, sigma 2, like that. While comparing these two, you know that sigma is less than sigma 1 because half width at half maxima. Here is this is shorter than this. So assume that now I have a feature, right? Some feature where the standard deviation is very small compared to 1. So what does it mean? It is as good as adding a column with constant values, right? If standard deviation is 0, how do you measure standard deviation? X minus x bar whole square by n minus 1 under root, right? Of course, summation. Now, if the data points are constant, that means there is no difference between data point and its mean, correct? Not significant. That means if all values are constant and you want to predict y, do you think this fellow is in contributing to prediction of y? If all values are almost same? Hello? Can you answer in the chat, please? No, correct. Yes, you are right. So that means that gives you a hint that you can drop those columns, right? But interestingly here, this is not the null values. It is entire column. The spread is, it is not, there is no distribution, right? It is just a constant set of values. So again, that will not add any value to your overall prediction. It will not have predictive power for y. So you drop those kind of columns, right? And similarly, there will be a lot of outliers, right? So outlier means what? let us say abnormal values. So how do you analyze outliers? Using box plot, right? So suppose if you have a normal distribution, something like this, of some x, this is my x. Now your equation is normal distribution of x given u comma sigma is sigma e power minus 2 sigma square, right? This is normal distribution. Now, when you say box plot, what you do is that you kind of normalize this using chart normal form where you set x minus mu by sigma is equal to z. So you will be having 99.9% of the data within plus or minus 3 sigma. Remaining data points will be somewhere here. You represent, assume that this is your mean. For normal distribution, your mean and median and mode all are concentrated at the same point, right? So you construct a box plot like this, where this is your median and this is 75%, this is 25%, first 25%, 70%, and this is called whisker, this is minimum, this is maximum, anything above these are outliers. So to deal with these outliers, right? Again, you have options like you either set these outliers to median or you drop them completely. So to take these kind of decisions, one will be looking at size of the data set and try to understand uh, how it works, right? So that's how it is. Are you able to understand what I'm saying? Ah, because mean is what is median? Let me explain here. Suppose I have values something like this, right? Uh, Values I have 5, 2, 1, 100, 6, 9, 15, 99, 3. Now, what are the abnormal values in this? The abnormal values are 99 and 100. Why? Because they are very large. Remaining are more or less you can manage, right? So if you sort them, what is the list that you get? 1, 2, 3, 5, 6, 9, 15, 99, 100. So mean means you add all these values and divide with by num. How many values are there? So when you say mean, you get 1 plus by 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values. Now, on the other hand, if you take median of this, right? Median means you just sort and remove the endpoints recursively and you have middle element after sorting. So median is 6. Now, when you compute mean, you are considering these outliers and they will blow up your mean value. In the case of median, you sort the list and remove these from both sides until you get midpoint or two middle points, right? So that means your median is not susceptible to outliers, right? Because you are eliminating outliers in median. That is the reason. Is it clear, Yogesh? Okay. But we are still at a very basic level, so we need to move fast, considering the scope what we want to do. Let me just uh, share again. So these are the some of the transformations. Suppose you want to construct a new feature, like you have weight and height. You can construct a new feature called BMI, body mass index. What is the formula? Weight by height scale. Sorry. Yeah, height by weight square or something, right? Isn't it? So these are new features you are constructing using existing features, right? Then next is visualization. You can use different charts and then you build a model and evaluate the model and all that, right? Now, when you're developing these experiments, right, one important thing you should understand is infrastructure requirements, right? Nowadays, people are talking about federated learning, distributed training, and all that, right? NVIDIA, thanks to NVIDIA, because the kind of infrastructure we have, like CUDA environment and things like that. I will show you some example, right, on how it works. So fundamental thing we should understand is CPU versus GPU, right? So in case of GPU, you have thousands of cores, whereas in CPU, only a limited set of cores. And another aspect of GPU is that these small cores, they can work together in parallel, right? So to train models which are uh, complex in nature, then the CPU environment may not be appropriate, right? So these are the some of the things that you say NVIDIA, RTX, etc. Now, next thing is how do we use this NVIDIA CUDA platform, right? I will show you a demo here. Let me share my screen again. Let me share. Yeah. Can you see the screen? Can you see my screen? Yeah. So let me see if you are typing in the chat. You can see my screen, right? So what you do is simple Google Colab, right? But since I work on, uh, you know, computationally intensive experiments, so I subscribe to Colab. So you see here, my current runtime is GPU with T4, right? So now what I do, because I am working on GPU, I can set up NVIDIA environment, right? So I will say NVIDIA SMI. It will give you complete details of, uh, let me run this code. Just run this. Now you can see here, right? You are importing data frame. These are the versions of NVIDIA, right? Like we have data frame in pandas, right? Here we have CUDA-DF, ML, etc. Right? So you can actually look at this. Let me share this. Let me share this link. Now it will give you complete picture of you know how acceleration happens for machine learning experiments on NVIDIA environment, right? See, this is the flow chart. So when you look at QML object on GPU, essentially what you are saying is that you have a program and you have third-party scikit-learn library, and you make a choice if you want to train the model on QML, then you have a native scikit-learn method. Then if you want that to be implemented, you call the functions, you get the result. Most important thing is, especially when you're talking about high performance computing, you will see that acceleration here. So this is a typical experiment. What you are saying is that you are, this is a scikit-learn code. You are just using scikit-learn, and this is a random forest classifier you have imported. Then from scikit-learn, you are calling make classification, etc., etc. The same thing if you look at uh, uh, on CUDA environment, right? It turns out that the algorithms which run based on scikit-learn on CPU, right? The similar algorithms on this CUDA environment found to be running 50 times faster than what you used to do here. So that is a computational power that you are achieving through these accelerators, right? So how it is possible? It is possible because you are able to execute these computations parallelly. So now question I have, any computation can be modeled in a distributed manner? Answer is no. Am I audible? Hello, you are able to hear me, right? So now let me share the whiteboard again. So we wanted to know whether all the suppose I have a data set. I want to run in a federated manner. So part of data frame here, part of data frame here, part of data frame here, like that. And I can combine the results. Sorry. That is possible if my computation can be expressed as sum of product of individual computations, like this. Sum of product of individual computations. That means what this computation indicates. It indicates this piece of element can be executed independently. This piece can be executed independently. This can be executed independently, but you can add them together, isn't it? So any computation which is of this particular form is most likely you can model it as parallel computation, right? So in case of machine learning, this is something similar is happening, right? So that is the reason these accelerators have a very big uh, important role. And in fact, in terms of infrastructure and accelerators, NVIDIA has lot of libraries, right? You can see from this thing. 1 minute. Let me just share this. So I will share this also. So to set this up, and these are simple classification tasks, right? You are loading some data set using URL, and you train using random forest classifier, and you try to get some score here, right? And same thing you can also do with, and of course you want to do hyperparameter tuning, let us say, using some grid set CV. Now same thing you can also try with code environment, right? 1 minute. Where is that? You can just explore this, right? Let me share this. So these are the good use cases for complex model development, right? So let me just go to the slide. Now let us look at various frameworks, how to compare them, right? So these are the various frameworks that we have. One is TensorFlow, for example. It's more suitable for deep learning kind of problems, and it is well suited for production level machine learning and pipeline development and things like that. On the other hand, there are multiple versions that you can leverage from, that is TPU support, and there is TensorFlow Lite also available. So it is based on a higher level of abstraction because it is essentially uh, look at like this. So it works based on computational graph, right? So one need to understand intricacies, all that. But once you get familiarized with uh, how to call the libraries and utility functions, then it will be easy. It's not that difficult. Similarly, you have a PyTorch, which is another framework which has uh, main utility of rapid prototype development. So it is Python flavor, and it constructs what we call dynamic graph. And there is a lot of community, open source community available for PyTorch, particularly helpful for image classification, segmentation, and object detection, right? For these kind of tasks, right? So PyTorch framework. Uh, Now scikit-learn, as I told you already, one example I showed you, right? Is a classical machine learning library. It will be useful for traditional task execution. Of course, Keras is on top of TensorFlow. There is something called JAX and Onyx runtime. It is for model optimization and things like that, right? So when you think of deployment perspective, right? For example, if you want to deploy certain models, then most popular is MLflow, which is easy to learn. Lot of tutorials are available. And similarly, you can also look at TorchServe, etc. Right? Like you have DevOps, we have MLOps. Various tools include MLflow, which is useful for experiment tracking, model registry, and things like that. Uh, it will it will track executions. It will track artifacts, right? And it is very popular. Now there is something called weights and biases. This is also like dashboard creation, collaboration logging, things like that. So is the case with Kubeflow and Airflow. Among these, most prominent are MLflow, Airflow. It depends upon the requirement kind of use case that you are dealing with actually, right? So now when you look at model types, right, there are two types of models we have. One is a discriminative model, other one is generative model, right? So in discriminative models, you have classification and regression or prediction. In generative models, they actually learn from statistical models, right? The data distributions like normal distribution, Poisson distribution, uh, and similar distributions, right? And if you look at Bayesian distribution, right? So things like that. So in case of discriminative model, you have a function y is equal to f of x, right? And generative models are probabilistic in nature. Then comes large language models, right? Most popular thing. So large language models, they are general purpose models, which can be trained, which can be pre-trained and fine-tuned for specific purposes. Large language models aim at training massive data sets, something like uh, language translation, right? And some other ML applications, NLP applications, right? So these are based on neural networks and that specific architectures that we use for this purpose. They are called transformers basically. So they aim at learning statistical relationships, right? So just a minute. Sorry. So, and then you basically fine tune these LLMs using some of the techniques such as prompt design techniques. And of course, you will use these for generative models like you generate text, images, and things like that, right? So when you work with large language models, right, one important side effect we should be cautious about, that is ethical and the security aspects, right? Because see, these models, they don't know intricacies, right? We as human being, we should have a kind of responsibility, when we are using it, like when you are creating new images, when you're creating new videos, right? We should be very, very careful about that responsibility that is called, right? So generative model, how it works, it is a nice diagram. You can refer to this link here. So first of all, you features, you convert them into a kind of input vector that you give it to generative model. From generative model, it will create some new examples. You compare that examples that are created by your generative model with actual real examples. So for that, you do a classifier or discriminative model. And there is a error you compute. That means fake image versus real image. Suppose if your discriminative model predicts that uh, correctly that these are fake images, that means they are quite far away from reality, right? So that's what you need to fine tune the model, looking at the feedback of the discriminative model. Any question here? You take the feedback and then fine tune this generative model. Do you have any question? Are you understanding whatever I'm explaining? Because otherwise it becomes one-way communication, right? You have to be uh, interactive. What is little bit? So first you understood the flow, right? We started with AI and then machine learning techniques. Yeah, I'm giving the links, right? The slides will be given to you at the end of the class, right? But you are understanding when I'm explaining generative AI architecture and things like that, right? All right. So these generative models, if you look at the broad classification, right? 1 minute. You basically start with density-based models and approximation method models, right? There are two primary classes we have for generative models. Within the density models, you have explicit density model and implicit density model. In the case of approximation models, you have variational autoencoders and stuff like that, right? So again, explicit models are something like GPT models, right? Or flow-based models are like example Glow. And there could be implicit density models, Delhi or mid-journey kind of stuff, right? So we must be familiar with these models, but they are actually developed based on certain mathematical models, right? That's why these implicit density models, explicit density models are important. But I don't want to dwell into all the details because we wanted to get into overview of various tools and techniques. So this is a brief description of what is what here. So if you see here, explicit density models, these models, they define and compute probability density function, and which allow these probability distributions to estimate what we call a likelihood estimate, right? So they don't explicitly define f of x, but rather learn a process that directly generate samples from desired distributions. What is implicit density models? They are trained to bypass the difficult task of calculating the density. Unlike explicit density models, they focus on generating realistic samples, right? So it involves a kind of invertible transformation, what we call a flow, to map a given distribution, something like Gaussian, to to a complex data distribution, right? So of course, at the higher end, we have variational approximation methods, which is called a kind of latent space and stuff like that. Okay. Now, classification model process involves data collection, data pre-processing, and feature selection, data splitting in terms of trained data, test data, and then you get validation, etc. Right? So you can think of some problem, something like Alzheimer's disease problem, and assume that these are the features. These are one of the data set from the UCI repository, right? So these are the features that we can think of, and these are we can perform correlation analysis on given data. In terms of data visualization tools, we can use matplotlib, right? And just create this kind of a heat map to understand the correlation between the features, right? For example, if you see MMSC feature, there is a negative correlation of a point minus 0.37, and you have NWBV feature with respect to age, you have minus 0.5. That means age increases. You can see this is getting reduced. Similarly, ASF and ETU. This strongly negatively correlated with zero point 0.9. Zero point 0.9 is very strong correlation, right? Now, I told you data transformations, right? What does it mean by? If you look at these two features, ETU and NESIF, you see a kind of a linear relationship. So what I do is I can fit these two features into another equation, something like this, right? Something like this, and try to use it. So what is my fitting line? Is a feature is equal to some weight into E2 feature plus constant. So I drop is a feature or E2 feature, one of them, right? So through which I can construct the model. See, most of the literature work that you see, right, whatever published, they're either interested in the computing the accuracy, precision, recall, rather than performing risk modeling. Here I'm showing you how we can perform risk model for a particular data set. So you can create a risk mapper, high risk, low risk, etc. For various models you can think of, and what are the features that you select. There are some feature selection techniques, but we don't have too much of time, right? We don't have much time actually to deal with all this in detail, but I wanted to show you how we can develop these models, right? These some results that we are getting. this is one of the work that I have done. And similarly, I also run experiments on Colab. Let me show you some of my works using these PyTorch and TensorFlow kind of tools. Let me open. So you can think of multiple experiments. Okay, so let me take this. Again, this is one of the uh, deep learning experiment that I am running here. I'm executing here using you know NVIDIA framework that I was talking about, right? So using PyTorch and a combination of NVIDIA. So very beautiful models you can develop actually uh, using this distributed computing, something like this. All right. Any questions you have? So what I suggest is I will share some resources also with you so that you can explore them, right? Because that's what I just showed you, right? SP Umayyan. I demonstrated that. Now, how do you construct this? How do you perform this analysis and things like that, right? So these are all Python code. I don't want to actually delve into details of this, but overview you should get, right? Because you will have an exam which is coming up, right? So it is important that let me share this. So can you see this screen? So this is a experiment that I'm running using one of the NVIDIA frameworks. Can you see this Jupyter Notebook? Hello? So this is how I set up the environment and how do I develop the model, right? Now, this is basically complex image processing, right? Now this is how the results you get. Multiple experiments you can run. And look at what I am working on T4 and GPU. Okay, then only you can work on these complex data sets. So with that, I will stop here and any question you can ask me. You have any questions? So suppose you can maybe ask that what the approach to problems, what kind of tools I should use for a particular scenario. You can ask all that, right? You might be working on some research. You can ask what I should explore, right? So fundamentally, if you want to uh, do research, right? So a minute to probably look at. First thing is you need to pick up the domain. You need to pick up the particular domain, right? You need to pick up a particular domain. Uh, with okay, being mechanical background, how to approach and implement ML in specific. Good. So that's what I said. Suppose I am from mechanical background. So I need to pick up a particular domain. You tell your domain. What is your domain? Uh, so suppose you want to predict some tensile strength or aerospace engineering. Let us take aerospace engineering. So I will show you something very interesting. Give me a minute. You can just go to this website. I will just share a screen and I will explain you how it works. Let me just figure out. So you can take up something like this, right? Uh, Let me share the screen. Uh, Can you see in the Kaggle you have aerospace images, right? There are 7 classes of aerospace images. Now you can run a small experiment where there are different images you want to classify, let us say. Airliner, balloons, warplanes, rockets. So these are all images. So you can take this as a multi-class classification problem and try to run some experiments on this. Right? Similarly, aerospace structural design data set. So let me share this with you. I am giving it here. Is it okay? So you know how to get these data, sample data sets, right? Tejaswini? Hello? No, I just shared in the chat. You are able to. No, no, no. I just shared the chat. I am sharing my screen. Let me share this. Oh, can you see my web page? Yeah. So this is the data set, this sample data set, dynamic mechanical behavior analysis. It gives various things, right? Various structural design element aspects it will give you. You. And it will also give you kind of task that you want to do here. Target variable is outcome of the process. So these are the features. So these are target variables. How much, what is the vibration damping, computational time, weigh efficiency, durability, right? You can choose one of these. So like that, right? So similarly, suppose you want to you get all the details here when it is published and similarly, you have investigating of aircraft weight and balance. Suppose if you want to- you get this another small data set. You can actually look at this, right? So whichever you like. Now, what are the steps that you have to do? Okay, suppose you understand the data set. What are the steps that you have to do? So let me explain on the board. So here, first you need to pick up the domain. You're able to see my blackboard, right? Hello? Can you see blackboard? Yeah. Now you pick up the domain. Next, you pick up a data set. Isn't it? And after that, you will be doing certain steps. What are the steps that you do? Like I showed you, right? First thing is you perform. Now experiment, setup, right? So you decide whether you need, you know, a GPU type of environment or normal environment. Let's say you stick to simple CPU, so you can use Google Colab. What is the tool stack that you want to use? You want to use scikit-learn, and after that, if you want to run deep learning models, you can use Keras and TensorFlow, right? Okay. So let me share some example on how to run this Keras and TensorFlow example, right? So meanwhile, I will share that. So first thing is step one. This is data ingestion. That means from given data set, you construct a data frame, in-memory data. Now next what you do is for each column, you identify how many unique values are there. Explore data. That means you can say simply data frame.info. When you call data frame.info, it will give list of columns and their types, right? So After that, what you do is that you also look at number of unique values for each column. So I will say for current column in data frame dot columns, right? def of current column. That means you are just taking current column in the data frame and you are printing all unique values, right? For every column. Now, once you print that column, you can put some star marks, right? Before that also, you can put some star marks like this. So once you get this, you will get a fair idea of, what are the unique values. So there is something called a df dot shape also, which will give you number of rows and columns. Number of rows and number of columns. Isn't it? So once you do this kind of exploration, then you will be doing outlier analysis, right? Perform. You are understanding the steps, right? You perform outlier analysis. Then I'm outlier analysis, I already explained how to do, etc. Right? After that, you will be doing some encoding here, right? After that. So encoding of categorical feature. So there are two types of encoding you can think of. One is using dummies, other one using binaries. Suppose I have a column called gender, male, female, right? So one way of doing it is you create two columns, underscore male. If actually person is male, you put 1 here, 0 here, like that. But unnecessarily it will include many columns, right? Another one is you can think of this is basically dummy. Another one is one hot encoding. That means you put 0 for male, 1 for female, like that. Because model cannot understand characters, right? It should be numbers. After that, you have data set. You split the data set using train test split. Okay. So you will get train data, you will get test data. So assume that these are the train data. And you run the model on training data to construct, to instead of run, you train the model actually. Train the model using this data. After that, use the test data to predict, evaluate the model using test data. Now, one of the important thing is called confusion matrix. What is confusion matrix? Suppose you have actual predictions, right? And you have sorry, actual values, you have predicted, model predicted values. Let us take an example of binary classification problem. Right? So in binary classification, let us take, you are predicting diabetic or not, right? Same example. So here, actual true, actual, positive class, negative class. Positive class means the record is diagnosed as diabetic. Right? Similarly, in predicted also, predicted as positive, predicted as negative. So when you just draw this matrix, right? You have these columns. So this cell, that means, is called true positive. That means the model is correctly predicting as positive, because model is predicting as positive, the actual record is positive. Similarly, in this case, model is predicting as negative and actually this is true negative. But here what happens? Actually it is positive record, but the model is predicting as negative, incorrectly classifying as negative. Isn't it? What is FN? Classifying a record as negative. Now what about this one? Actually is negative, you are classifying as positive. So incorrectly classifying as positive. Now we define some metrics here. One is called accuracy, correct positive plus correct negative divided by correct positive plus correct negative plus false positive plus false negative, everything. There is something called, next one is precision. What is precision here? True positive be predicted. Out of all positive examples that is predicted, how many of them are actually positive? Similarly, there is something called recall. Recall means true predicted by P actual. Suppose if you are doing a medical diagnosis, right? Which measure is important? Recall is more important. Because out of all patients who are potentially having the risk of cancer, your model is expected to recall all such patients, right? Because if the model is poor in recall, the problem is what? High risk. That means model is incorrectly predicting as negative. If somebody is diagnosed as negative, but the person is actually positive, what's the problem? He will be missing taking precautionary measures, isn't it? Are you understanding? Hello. So actually putting all this, you have a F1 score here, which is nothing but 2 times precision into recall by precision plus recall, right? So these are the some of the measures that we'll use, right? You should remember this. You can always find this in scikit-learn. Go to the scikit-learn website. For example, let me just try. I will share that link also. Please visit all the examples from this. It will help you. So let me share my screen again. Can you see my screen? Hello? See, these are the different algorithms, how to implement. Suppose I want to do some example for query process. This is an example. How to there is echo I am getting actually.
Yeah, I joined.
Yeah, no problem. So, so this library will give lot of experiments, right? Like how do you load the data set, right? It will give you examples. Suppose you take diabetes data set you want to load. So these are some of the parameters. Now, for each of them, you can have links, right? I already shared this link, which will be very helpful to you. So, like irrespective of your domain, right? Your domain knowledge is very important. Don't lose your domain knowledge. Somebody said aerospace engineering, right? Still, you can use problems from the domain, try to figure out how machine learning AI can help you in that, and come up with some kind of proposal on that, right? Using these techniques. So it doesn't matter, even if you are physics, chemistry, whichever background it is, right? So use that domain knowledge. You can always get these techniques. It is not very difficult. It is difficult, but not very difficult. You will be able to run experiments and visualize this. The way I showed you the demonstrations, right? All right, I think I will share. I will stop here because Kamna is waiting for concluding the session. So thank you so much, Kamna, for the opportunity. And
No, no, you finish. You finish. No problem. I
no,
think
I'm done.
Dr. Gopal is waiting.
Yeah,
I'm
yeah,
more than me. He is waiting for his
yeah,
session, which is
yeah.
almost
Good,
time,
good.
and you finished on time.
Yeah,
So,
yeah, yeah. Thanks. Thank you so much.
thank you.
Thank you.
Thank you so much. We look forward to again having your session tomorrow
Yeah,
at
yeah,
6.
yeah, yeah.
Yes.
Thanks. Bye.
Thank you. Thank you so much. And now it is my pleasure to welcome Dr. Gopal, who is ex-professor at Anna University. Sir, I'll request you to come on camera.
One. Yes.
Yes, Dr. Prakash, you can stop sharing your screen if you're there. Yes.
I stopped
Welcome,
sharing.
Dr.
Yeah.
Gopal. Thank you so much for joining us and taking this session, even though you are traveling. And I think you have a new assignment, as you were mentioning. So it would be nice to hear a little bit about that also.
Just joined as an adjunct professor in the morning today, and just about getting ready, got my office room and a place to stay here on the campus. From tomorrow, my lectures will start, and I'm looking forward to the lectures. Some work will be there, and I'll keep talking about the new assignment as we progress. Retired from Anna University on 30th June 2025, and I was a professor there and also a director of a Center for Applied Research in Indic Technologies. Have been with NASCOM for ages, right from its foundation days, and most recent one was working on a coursework, Foundation Skills for Integrated Product Development. It was a very nice course. We were able to come out with 176 trained trainers out of Anna University, various colleges. Uh, Going through these experiences, I think, I'm finding this intellectually stimulating exercise to talk about the latest technologies to the faculty members so that the news will spread, students will benefit from these interactions. So I suppose if Kamna permits, I'll get started with the screen sharing.
Yes, sir, absolutely. Thank you so much.
Nice. Thank you so much. Please give me a feedback if the shared screen is visible.
Yes, it started coming. Not yet visible though.
Okay,
Yeah,
good.
now it's visible now.
It's
Yes.
visible now. So what I will do is I'm controlling the slides myself. And as we progress, we should first understand that the topic is not entirely new. The idea of spreadsheet, Excel was there for ages. Somewhere we will understand that one of the most important office automation tools that has ever emerged in the last 50 years is Excel. So, where is the point that we are focusing on today? It's on the generative pre-trained transformers, which are doing wonders on what we were normally calling chat by emails, snippets here and there. A lot of electronic or digital content is around, and using what is called a large language model, a generative pre-trained transformer has been created in quick time, let's say from 2017 to now, 7 or 8 years. It has caught us wondering about what is it that we can ever do now. Everything is generatable. Just ask a good question, just ask a good prompt, then everything is done. My colleague Dr. Prakash Goteti was also mentioning the same. What is it that we are in for? Is a question. If everything is done automatically, we are not answering that question directly, but then let's see how we evolved into Excel and then putting forward the ideas on what ChatGPT can do with Excel. It's amazing things. Amazing things. Right at the beginning in October, I was also one of the instructors in this course. I had the opportunity of doing the preliminary introductory lectures on ChatGPT and then prompt engineering. Both of them were giving me valuable insights. Again, please do not hesitate to interrupt me. Please do not hesitate to ask a question in the chat. I'm just trying to see how to get onto the chat as well and also change the slide. So let's get on with the exercise. The idea of a spreadsheet is not something which is completely new by any yardstick. We have been using that for ages, and see how we are doing these things. A very commonplace idea. Expenses on 4th June 89. This is a much more structured ledger sheet, which is not fully a ledger, just a notes on 4th 6. So, as of date, expenses have been for the hotel, breakfast, lunch, dinner, total on 4th of Tuesday, Wednesday, and then the total. That's what has happened until 6th. On 4th, some money was spent on these items. Head of account has been created. We are just keeping track of what we have been doing as expenses. As a matter of fact, this was considered a very, very important discipline. When I joined for my first job formally in 88 in Chennai, this was maintained by me. I had a notebook, these columns, expenses, close the accounts on a given day. To close the account on a total date, check the balance and keep it. Though the heads of accounts are different, it is something which we need to understand. Now you imagine the same idea of tabulating. What is it that you are doing in terms of expenses over a span of several days, several weeks, several months, more entries, not merely expenses, but just say accounting. We just want to do it. Now comes the question, becomes very cumbersome. So what was happening was we were just closing it, file it out and go ahead, file it out and go ahead. The matter of accounting discipline, which was considered very important, the account section will take it forward from there and push it out. Now, if each one is generating one sheet, I was in a small organization of about 20-25 employees. Each one of us will give one sheet. At the end of the day, well, with a little bit of friendliness, within a week, all of us would have submitted all 5 days of accounts. 5 into 25, 125 pages like this will reach the accounts section. Every week, 4 weeks, it's about 500 pages. Now you see the concern. They have to go through the rigmarole of doing this exercise of cross-checking, finding out. Now there's no interactivity here. There is no change. I've done it, I'm submitting it. Now, is there a way in which somebody can check, are you exceeding the balance on this particular head of account? The heads of account are nominal. What I indicated was hotel food, but can be anything. How do I check? There's no internal check. I have done this. If I forgetfully spend more on that, somewhere later it will be found. Next month it will be found, not now. Very cumbersome procedure. The same case with the payrolls. Payrolls is the much celebrated package, software package that was ever developed in-house. We ran manually, we checked, tallying was done, accounting was happening. Now let's look at the paper ledgers accumulating. We were not so structured. There were no pre-printed stationery, but then big sheets of paper permit storing figures properly. They can be found even after 4 years, 5 years. Now, what is the account section doing? The account section is collecting all these 500 pages submitted every day, all expenses done, into a ledger. That's much more neatly classified, gives a bigger picture about what is happening across the organization. So how do we tackle this concern was a question. It becoming too cumbersome. Large organizations required many more such exercises. The account section will become much more in numbers. People become much more in numbers than the normal people who are working. Big concern. So we thought that it's a mainframe that's necessary. LangPAR was created, language for programming arrays at random. People will come, people will give, and then we should be able to put them whenever the page comes, push it into a ledger, push it into that automated software and account for it. There's no reason why it should come in as a sequence. We can't wait. We can't wait for all things to fall in place. Widely recognized as the first electronic spreadsheet application developed in 1969. Not now, let's say 5 decades. As I said, 5 decades, definitely 5 decades for this idea to mature. By René Pardo and Remy Landau. It was designed to solve the issue of manual, tedious, and time-consuming budgeting for companies like Bell Canada and AT&T. Large companies, they have to pour over all these accounts. What do I do for the next budget is based on what I am doing now, what the organization is doing now. Making changes to the budget models took weeks or months for programmers. It was created specifically to automate the budgeting process for large corporations on mainframe computers a decade before VisiCalc brought spreadsheets to personal computers. So it was done on mainframes and forerunner for what became a popular spreadsheet. Popularity because it's a good idea. Each one of us need it. Second reason, it's on personal computers, PCs. LANPAR was the trailblazer for the mainframe era of spreadsheets. Pardo and Lando filed for a patent in 1970. After 12 years of litigation, they won a landmark case in 1983, establishing that algorithms in software were patentable. So, with three reasons why LANPAR became a forerunner for many, many, many exercises to come. One is it was the mainframe. Second, spreadsheet. Third, patenting software. So 12 years of litigation, well, they could do it. It's something which we will have to admire on them. Uh, LANPAR was not such a fascinating user interface. It was more like doing it off on punched cards. Towards doing it on punched cards, formula translators. So very, very weak, up to 99 columns, 999 lines. Boxes can have constants. They can have inputs. They can have calculations or simply be empty. Each box, 900, how many rows and columns? 999 rows, 99 columns. That's the limitation of that spreadsheet. You can keep on posting, keep on providing the calculations, or if the user input is necessary, it will prompt for input. Very simple. As the exercise goes on, it gets tabulated. Now, we are not really looking at anything more complex than pushing it into a nice table structure, a simple language to program, and we have these features. Forward referencing, it allowed a cell to reference another cell that had not yet been calculated, which was a revolutionary concept in 1969. Natural order recalculation, less advanced tools that had to calculate left to right, top to bottom. LANPAR could calculate in the correct order regardless of where the formula was located. There was no need to spend time on sorting. There was no need to do that. Just connect the cells, the formula will come. It's programmable in that sense. There's no need to have ordering of the lists or left to right or top to bottom. Interactive operation, although not a WYSIWYG, what you see is what you get. Graphical interface like later PC tools, it was used interactively via terminals, modems, faster, more agile budgeting. Now you see how this entire exercise got automated and distributed. When was this? 1969. That's clear, 50 years plus. And it's a landmark idea to talk about LANPAR. It's programmable. Nothing is cast in stone. Anybody can submit anything. You can connect everything. Now imagine the chat GPT as we are chatting. Let's say we are connected to the distributed stock exchange. Automatically, all lights are going to change. All those indicators are going to change as we speak. It's very much possible. Let's go on. So, Dan Bricklin, 1951, VisiCalc. This is something interesting. LANPAR is stemming out of what I described. All organizations were having this, and unless you account for what has happened so far, how will you budget? What is the next budget going to be? How do we estimate that? Questions? More questions, but LANPAR gave us a nice programmable array where there is no need to have a location for a cell. Just do that, connect it properly using the code, it works. We are bringing back that flexibility again with ChatGPT. For a while, we were obsessed with the cell, the row, and the column because of the typical standard spreadsheets. Now we don't have to do that. LANPAR features. Dan Bricklin in 1917, that's a decade later, visible calculator. It's called VisiCalc. He did it for Apple II, and it pushed the sales of personal computers like nothing else has done before. VisiCalc was the first electronic spreadsheet software released in 1979 for the Apple II and is credited with driving the early adoption of personal computers in business by transforming manual financial analysis into an interactive automatic process for creating what if scenarios, essentially creating the killer app that made PCs essential tools, not just toys, by replacing tedious pen and paper calculations. Pen and paper calculations have virtually vanished after all this spreadsheet and everything came. Now we don't even need just talking to your microphones. Simply get chatting with people around, build some commerce, and automatically the scenario is becoming very obvious. Early adoption of personal business by transforming manual financial analysis into an interactive automatic process for creating what if scenarios. Just say, I want to change it out here, it changes. As we progress, we'll see more. What is happening now with that integration? How did VisiCalc happen? In an interview, Daniel Bricklin told how he got the idea to create VisiCalc. In the classroom at the university, he watched the professor draw a table on the blackboard where he entered the results of the calculations. When an error was discovered in the calculations, the teacher had to erase and re enter the contents of several lines for a long time. Understandable. This gave young Bricklin the idea that this process could be replicated on a computer. The board in this case served as a model that demonstrated the results of the basic formula. The first VisiCalc spreadsheet was born in that sense. So, what we have been talking about is a simple idea that happens in a classroom will now be the foundation for many things to happen on the software. So VisiCal's screen was looking like that. Developed by Dan Bricklin and Bob Frankston, it organized data in a grid of rows and columns. My earlier speaker, as I was listening to, was talking about voluminous data. Voluminous data. In the land par, it was 999 rows, 99 columns. All these pieces of software do have a limitation on the number of rows and number of columns. But now, once it is distributed, things may be looking different. Automatic recalculation, a number changed. A revolutionary feature that laid the groundwork for modern spreadsheet programs like Excel. What is very, very important in VisiCalc is what was revolutionary in that when a number gets changed, the related cells will automatically get recalculated. The idea is the same, but now are we needed to do that is the question. Is agentic AI enough to do that? What is it that we can think about? So, this is how the old black and white terminal was looking like it. Software Arts Incorporated. It happens like that. And there's another screen. You can mark a cell A1 and then type out whatever you want. It goes and sits. A small editor, cell-wise addressing. So you remember 10 years back, 10 years before VisiCalc came, it was programmable. Don't worry about the cells. Just point out where you want it to happen. It will happen there. Let's not be obsessed with this cell numbers, row number, column number. But then we'll have to be for pragmatic reasons. VisiCalc came out with a slightly, these are all changes in the way the interfaces happen to VisiCalc. The core idea remained the same. We got some more functions, F1, F2, look at the bottom of the screen. The way we are editing into A1, A2, A3. Now I don't think I'll have to type, I can simply pronounce it, it happens. Wherever it is, not necessarily here, it can happen in any targeted machine that we are talking about. A little bit of hyperbole, but please do permit. Teachers are like that, will create a bit of a scenario out here. But then the entire VisiCalc is teacher's delight. It happened from the classroom context. A teacher was practically struggling, and something happened with the students. So F, E, S, G, P, all these things, these are the ways in which the VisiCalc has improvised on the interface. The terminals were very rudimentary. Talking about 7980, the terminals were rudimentary. A decade later, the same thing I was using, but with something else, with Lotus 123. The next spreadsheet has taken over. So when I began teaching office automation in 88, 89, the terminals have not yet so improved, but I could see color. Graphics adapters were there. Color monitors have just begun to happen. This screen was a reality. I've seen this screen, but for the Lotus 123. The idea is the same idea. This much of complexity, we didn't know what to do at that time. Apple screen, we didn't have Apple machines. Apple permitted putting together of many screens. Now, these things are understandable. See how simple the idea is and how revolutionary it became as we progressed, just under 50 years. SuperCalc is a spreadsheet developed and introduced by Sourcing Technologies in 1980. It first included the CP-M operating system for the Osborne 1 portable microcomputers. CP-M was a very, very rudimentary operating system. It was not such a sophisticated one. What I am driving home now is the hardware, the graphic displays, the connectivity, the graphics adapters, the way in which we can manipulate the graphics themselves, not necessarily the data, and then the ChatGPT on top of it, a very sophisticated operating system working for us in a connected system. SuperCalc appeared as a competitor to VisiCalc. In late 1980, the creator of the first commercially successful portable computer, Adam Osborne, was looking for someone to sell spreadsheets for his brainchild Osborne 1. It was a portable computer. Later on, Bill Gates called it personal computer, and we move into the Excel very soon, very soon. He wanted to acquire the rights of the VisiCalc but was refused. The VisiCalc itself was like that. Then he asked Sourcing Technologies to make a table for him that could compete with VisiCalc. They did it at the cost of $20,000. SuperCalc was bundled with Osborne 1 and also sold separately. And this was first ported to MS-DOS. Microsoft took this SuperCalc. Neither LANPAR nor VisiCalc was available for doing anything outside of those organizations that created it. And VisiCalc is always a teacher's delight. We would like to spend more time on giving more examples, but it was all right. It was 88, 89. We were taking examples like that. Then came a great success story, Lotus 123 by Mitch Kapoor. Mitch Kapoor founded American Society for Designers, saying that what software lacked is a design. Until then, Mitch Kapoor was so fascinatingly brilliant that there's a storyline that tells that he picked up the idea for Lotus 123 while watching the horse races. You see, what is important to understand is I was in Chennai, very, very close at that time when I was teaching these courses. I was very close to a race course. I could go on a Sunday and watch. The people will be there very quickly as soon as the jockey, the horse name, and that's all. A jockey and the horse name combination will be announced. Immediately, the people who are there are reeling off what are the past races of this horse, the named horse, what are the past races of the jockey, how many times they were combined, the jockey and the horse, and how many times they won, based on which the bettings change. I still remember few minutes, hardly 1 or 2 minutes before the race begins, the jockey and the horse, both of them are announced. And how many have happened, how many such combinations won at that particular race course, all these things it could happen. Later on, things got very regularized, formalized. There was an entry pass. I stopped going there. We moved out of that place. But then I saw it practically happening 1 or 2 minutes before the jockey and the horse names are announced. Next 2 minutes, the race begins. Next 3 minutes, the betting is done. And all legalized betting, all in 5 minutes. And how many things they track? The horse, what is the track record in racing? The jockey, what is the track record in racing? How the combination has fared in earlier races, where, under what conditions, based on which the betting goes. It's not gambling, but it's racing. It's just a game kind of a thing. Now, all this, how do we manage? Not in a single spreadsheet. We need to understand that it should get connected to a database, because you should know where and all the horses were racing, where and all they won, the jockeys, the historic nature of the jockey. And now let me just change to the cricket analogy. The cricket analogy clearly says so and so batsman is coming, the entire track record comes. How many times it has happened, what is the last 10 innings. The idea is the same. Though I'm not really drawing a parallel, just giving another example. So you need a database, you need a way of spreadsheet to calculate what if and the bettings. And what he did is a wonder. He was not a typical technology founder, Mish Kapoor. He was a former DJ, a meditation teacher, obsessed with making computers more human. Spreadsheets existed, but they were painfully slow and unstable. Businesses were buying PCs, but most did not know what to do with them. The same case here, when I was beginning to start doing this, we popularized the usage of computers through office automation courses. Most certainly, Word, spreadsheet, and databases remained the core of that particular exercise. Office automation courses were a hot cake at a place where I was working. The world's first spreadsheet, VisiCalc, was brilliant but broken. He realized if he could build a faster, smarter, and more powerful version, he could change not just the tool, but the entire industry. He taught himself assembly language alone in his apartment, surviving off part-time jobs and persistence. What he built became Lotus 123, a spreadsheet that ran so fast that people thought it was fake when they first saw it. He called that because it could do three things no one else had combined: calculations, charts, and database. This is CHARTS, charts. It shows a graphic display of what is it that's happening. You can draw the graph and see that. It was revolutionary, but the brilliance was not just in the code, which timed it perfectly with the arrival of the IBM PC. It's a personal computer. When the IBM launched, Lotus was ready and it hit like lightning. Lotus 123 was a revolutionary spreadsheet program for IBM compatible PCs, combining powerful spreadsheets, data management, and graphics. That fueled the PC revolution, became the business software standard before being surpassed by Microsoft Excel. So when we were teaching the first office automation courses in India, very first iteration, 88, 89, we were talking about what was called WordStar, a Word package, Lotus 123, and DBase 3 Plus. These were the three different packages that combined together to make office automation tool set happen. Later on, integration happened, commercial concerns Developed by Lotus Software, it offered features like quick charting and database capabilities, making complex tasks accessible and driving personal computer adoption in business. So now it's all on mobiles, many things can happen. We are just seeing this idea build further. Early books, very, very famous books. There was no office that did not have this big fat book. A Lotus 123 made simple is a very fat book, DOS version. Lotus 123 for Windows, 123 for Dummies, Guide for Using Lotus, very old book which I could pick and look at it. Guide for Using Lotus 123. There was no organization that did not have one of these four books, big fat books. People have to learn. Remember, where is the complexity? Is not merely combining a spreadsheet, a database, and the graphics, but how to put it together was an exercise. How to take advantage of having a spreadsheet, a database, and a graphics package. That requires training. That requires understanding. So Lotus 123 is best known primarily as a spreadsheet, which is well supported by a database, well supported by a graphics package, and well programmed to harness the power of the hardware at the assembly language level. That's the brilliance that Mish Kapoor has put. To see how much of design has gone into his way of working. Then came Bill Gates, Microsoft Excel, originally written for Apple II, shipped with introduction of Windows with a great graphical interface. Spreadsheets, Excel calls it a worksheet. A workbook is a collection of worksheets, grid of columns. Each box is called a cell. Each cell is name. Every cell is referenced, which is the column letter followed by the row number, which was introduced much earlier. The ideas was there, were always there. You see, when VisiCalc's interfaces came, A1 was right on the top. We were able to see some edit lines, some function keys, and how to get color on the screen. All this happened with VisiCalc. That's about very, very easily 7 or 8 years before Excel happened. But then Excel had the advantage of a personal computer, had the advantage of a Microsoft happening, and that's Microsoft Excel. Excel forms a part of Microsoft Office suite of software. Microsoft Excel is a spreadsheet developed by Microsoft for Windows, Macintosh, Android, and iOS. It features calculation, graphing tools, pivot tables, and macro programming language called Visual Basic for applications. Visual Basic was a paradigm in programming by itself. It was a programming paradigm. What Visual Basic did was separate the back end and the front end. The back end can be databases. The front end is just a plain simple user interface. We don't see much of a complication. You don't need a real big fat book to understand how to use the spreadsheet, which is nice rows and columns, the database, and the graphics. You don't need a fat book at all. But then the fact is, Visual Basic was a language in itself, much like LANPAR. LANPAR was a nice, simple denotational language in itself. The very first spreadsheet, 69, Visual Basic for applications. Microsoft originally marketed a spreadsheet program called Multiplan in 1982. Multiplan became very popular for CP*M systems, but on MS-DOS systems, it lost popularity to Lotus 123. Microsoft released the first version of Excel for Macintosh 1985, for Windows version in 1987, roughly 7 or 8 years after Lotus 123 happened. Lotus was slow to bring 123 to Windows. In the early 90s, Excel had started to outsell 123 and help Microsoft achieve its position a leading PC software developer. Importance of MS Excel: easy arithmetic solutions, various formatting options, availability of online access, graphing. What really was very, very catchy about Excel was online access. Though at a time when we were doing, online access was not so popular. In addition to this backend of databases, in addition to different formatting options of your spreadsheet, it need not be the same old boring structuring. As Prakash was mentioning, a bit of an unstructuring can also happen. Graphing, it also had online access. It was very nice organizing data, human resource planning, and programming interfaces to Excel. These were something which were totally nice, very, very helpful. And by the time the idea of spreadsheet caught on into accounting, payroll packages were happening. Actually, all these provisions moved out payroll from the stranglehold of COBOL programming. We can do it other ways: human resource planning, programming, data organizations. Simply, Excel has had the underpinnings for all this. It already had it. Basic features: a grid of cells, numbered in rows and letter named columns to organize data manipulations like arithmetic operations. That was fascinating. I can build into the cell an arithmetic calculation. Most of the times of the last, even now, it was so common to discuss tabulating internal marks, tabulating project review marks. Just get that Excel, we'll punch it in. We were making that we were making that Excel sheet. Into each cell, the numerical formula can be made. Answers statistical, engineering, and financial needs. It's the robustness of this package that made it popular. It's not that it has outsmarted or outperformed Lotus 123. As I said, LandPar, VisiCalc, SuperCalc, Lotus 123 are four exceedingly brilliant pioneering exercises. And Microsoft added on its own the online, the arithmetic calculations in the cell, and how it relates to and how it transforms to other cells, learning gradually from 1969 to 89. Let's say 20 years. 20 years is not a joke. It's a huge time that has happened. Display data in multiple forms, line graphs. You can choose graphs, histograms, charts. Allow the user to employ a wide variety of numerical calculations. It's very interactive. So what has happened was the operations. How are the operations happening? Very structured, very neat, very easy to understand. Use the formula. Is an expression that operates on values in the range of cells. You can mark range of cells. You can mark range of columns. How many cells and columns are impacted by this formula? It will tell. All those cells will automatically be updated in the Excel. Functions are predefined formula in Excel. They eliminate laborious manual entry of formulae. While giving them human-friendly names, the function will have a name. You just simply say sum. It will go ahead. The same advantage. You see how much of an essence of programmability was brought into this Excel. Very ingenious. Huge code, well developed, and well integrated with Office products. So where is the question? It brings in all of that under the typical same common user access. The interface is the same. So the functions are there. The overall view: Excel offers many user interface tweaks over the earliest electronic spreadsheets. Excel became the first spreadsheet to allow the user to define the appearance of spreadsheets. There's no more hard and fast rule that the spreadsheet must appear like this. It also introduced intelligent cell recomputation, where only cells dependent on the cell being modified and updated. Excel introduced many important features. Excel also has introduced extensive graphic capabilities. You can draw a line, you can draw a bar, you can draw a pie chart, you can have a choice. So, this is the story about how, according to me, necessary to understand as we progress towards the next set. That is, start with Excel, understand how Excel was so important for accounting, for financial analysis, for budgeting, for planning. Everything is Excel. Why only student tabulation of marks? It's just an Excel. Get me an Excel for 120, 200 students, we are done with it. So that's how it is. So let me just quickly summarize. When the cumbersomeness of manual writing on pieces of paper, many people writing it, posting into the ledger, paper ledger, tallying it, all this became so cumbersome. Even with 25 employees, it was a big exercise. Hardly one accounts person was there. One part-time accounts fellow will come. And unless the accounts fellow is clear, my next month's salary will not be released. Head of account. So it's something which we are doing it. But then it's so cumbersome. Likewise, payroll. The account section is very, very serious about monies going to the employees by 1st of every month. Racing against time. Errors were creeping in. They have to do more work. So LandPower is the first one. Very pioneering effort on mainframes. Then came Dan Bricklin's VisiCalc. As I said, it's a teacher's delight. It happened out of classroom teaching. VisiCalc, I cannot resist collecting these pieces of screenshots, each one an improvisation, how the cell should be there. And then it was on Apple. Apple had the best user interface. You can put together all these things. I never used on Apple spreadsheet. Never worked on Apple so much, but I'm using it for an example. They were almost made for one another on the Apple Macintosh. Then came SuperCalc. Then came Lotus 123. And Lotus 123 is scintillatingly close to what we have been envisaging in this lecture. Put everything together in any form. There is a spreadsheet. There is a database. There is a graphics package. 1, 2, 3. All three were done together, extremely fast. But then to harness how to use these three ideas together with spreadsheet in the focus, big fat books emerged. There was no organization that did not have these books. Introduction to Excel, I have done that. Excel gives you online access, graphing, various formatting options. That is what was the Apple success. Please see this screen. There's a reason why I put Apple's success was different spreadsheets can be chipped in onto the same screen to give you a feeling that what happens if we look at it together. The same thing will happen on what is called the Microsoft Excel. I'm sure you are seeing the slides change. You see this particular slide, it gives you a feeling that's an Apple Macintosh-like interface. That was a great interface which they could think of. Let me halt for a few minutes here, field any questions before we go to the real topic that's putting together ChatGPT and the spreadsheets, Excel. Any questions in the chat? Oh, thank you. Thanks for the nice words. I'm just waiting for a couple of minutes before I move to the next one. So this is how we built it. Innately, Excel is quite capable, quite powerful online tool. It can go ahead, it can work in many contexts. Now we are seeing the power of ChatGPT getting integrated with the Excel. So this is what is the next step for me, integrating ChatGPT with Excel. Very nice topic, very challenging topic, but it had, I was simply interacting with Kamna saying that it makes me race nearly 30 years back in my career and how we were working on it, how Excel came in after Lotus 1, 2, 3. Things happened, many things have happened, but right now it's all Office products. Integrating ChatGPT with Excel. ChatGPT is highly relevant for Microsoft Excel, acting as an AI-powered copilot that automates tedious tasks, voluminous data, generates complex formulae, and analyzes data effectively, transforming beginners into advanced users. Later on, I picked up some examples and gave a chat sequence towards the end of this lecture. By integrating ChatGPT via plugins or direct web usage. There's a plugin possible for Excel on ChatGPT. OpenAI is also giving a plugin. It's just there, another simple button to punch in Excel. Significantly increase productivity, often saving 5 to 10 hours per week by reducing time spent on manual data entry, formatting, and formula debugging. There's no point in picking up data from one column, pasting it in another column, and or get it from other spreadsheet, put it here. Please have a chat GPT plugin, and then you can easily maneuver many things. Formula generation and debugging. ChatGPT can create complex formulae. That's something which is a great advantage. The idea of a formula coming is very, very unique to Excel. We can create some functions, we can create some formula, nested if statements. It's a very good idea. So what ChatGPT is able to do is based on simple natural language descriptions. It can debug errors, it can analyze formula and help you out. Very, very powerful. Data cleaning and organization. It can clean messy data sets by removing duplicates, splitting text into columns, and fixing formatting issues like date formats, phone numbers. Automation via VBA and macros. ChatGPT can write VBA code for macros to automate repetitive tasks without requiring the user to have programming knowledge. Data analysis and visualization. With advanced data analysis, GPT-40, users can upload spreadsheets to generate summaries, identify trends, detect anomalies, and create charts directly from natural language prompts. Structuring unstructured data, it can take raw, unstructured text. I must thank my predecessor speaker, Dr. Prakash, who has done this nicely, and he could use some simple interface tool to teach that also. I was also watching it. I couldn't resist thinking of Lanpar. See how nicely he was writing it up on the whiteboard facility, whiteboard tool, and how many times he has to go back and forth teaching how the impact is there of one exercise happening on the other one. The same example which happened with VisiCalc, which the teachers delight always. It can take raw, unstructured text like data copied from an email or report and format it into a structured table in a Ziffy. And it looks very authentic, very consistent. All formulae are quite consistent. Visual Basic Applications is a programming language built into Microsoft Office like Excel. How many of you have used VBA? Please respond in the chat. Okay, don't worry. Visual Basic Studio. I got the answer. Thank you. You see, Visual Basics was a paradigm shift in programming. Programming has seen several approaches, several directions, several paradigm shifts. Visual programming as a paradigm gave us the ability to limit what is happening through the browser only to the interface. The actual work happens in the backend. It's a very good idea. Alan Cooper, who came up with this idea, later on sold Visual Basic to Microsoft. They all happened as Visual Basic for applications. It was built into Microsoft Office, creating custom functions. By the way, Microsoft Office, which I'm using now, even now, right now, to share the presentation, has a common user access, again championed by IBM, but it's always there. It's there in Microsoft. It's a roaring success and very nicely done, well thought out. Very good interface is there. Custom functions extend application capabilities beyond standard features, primarily through writing macros in the Visual Basic Editor to handle repetitive data processing. If you want to do the same thing over and over again, just simply use a macro. The visual programming paradigm is much more better known as event-driven language. Why is it event-driven? Event-driven programming paradigm says, like we do each time these days, the windows is there, 10 windows are there. The window manager senses which of the window the user has clicked to work on it. So you can have multiple windows opening, and based on which window is triggered, you can operate on different tasks, put them together. The pluses of that Visual Basic have been so wonderful that it's a powerful medium. Now the user need not have 3 fat books to learn how to put them together, how to take best advantage of. Neither is a diploma course necessary. Just plug in ChatGPT and it starts happening. How nice it is now, productivity enhancer. 2017, Google revolutionized text generation. Google introduced the idea called transformer, which rapidly became the state-of-the-art approach to solve most NLP problems. OpenAI's ChatGPT, in 2022, as the name suggests, reposes on transformers. What is this transformer technology? It refers to a revolutionary neural network architecture introduced in 2017 that excels at processing sequential data like text by using a self-attention mechanism to weigh the importance of the different parts of the input, allowing it to understand context and relationships. That's what we do every time. What is the essence of what is being spoken? Forming the backbone of the modern generative AI models like ChatGPT for language, vision, and other complex tasks, moving beyond older models that struggled with long sequences. It's a great progress in the way we simply tamed the myriad ambiguity that's possible in natural language. Multiple parameters, faster machines, distributed, just plug into the chat GPT and we are done. So what is chat? Basically, in that chat GPT, chat is a real-time, text-based or sometimes voice video conversation between 2 or more people, typically online, that feels like a friendly, informal chat or small talk happening instantly through apps, websites, or services like WhatsApp, Messenger, or social media platforms, allowing quick exchange of messages, photos, or audio. It's a digital evolution of talking from simple text to rich media. ChatGPT is providing human-like responses based on anything that is digital. Though it began like this, chat has assumed many forms, many formats. Built on GPT-3 and GPT-4 for deep language understanding, it's used for a wide range of applications like customer service, content generation, and language translation. Please remember these good features. Later on, towards the end of this lecture, we'll see all these in action. Features of ChatGPT: versatile conversational abilities, subscription-based model, creative content generation, voice and multimodal interaction, code assistance, customizable and fine-tunable. Customizable. ChatGPT systematic literature review. How to do that is the question. Being an academician, I would like to put this in place. Tools like ChatGPT fall under category of generative AI, which is a subset of the broader field. In some sense, the usage of the term transformer is not exactly what is happening now. We are only generative. We are hoping to make it really transformative. AI-powered natural language processing, generative AI systems. So AI, machine learning, Dr. Prakash was taking you through all these things, generative models, output types. Working with AI tools, what is ChatGPT prompt? A prompt is something which is a communication in natural language. It works. Command line prompts, prompt engineering. So generative AI NLP tools, lot of tools are there. Copilot, Gemini, ChatGPT 4, ChatGPT 3.5. Today in the evening, I was working on the Microsoft Teams, and the Copilot is automatically up and running. It's easy to have that Copilot automatically up and running, but I did not know for a while how to get out of it. It just runs. The Teams is configured to do that, and it will just run. So what we have been talking about is many tools are there. ChatGPT is chosen for our exercise. It's definitely a runaway success, and I'm definitely thankful to NASSCOM, AIC, and AICTE for bringing out such a nice set of lectures and a good group of teachers. Kamna keeps on sending me the links of the earlier presentations. For this lecture, I had some time to look into the earlier presentations. It's cogent, it fits well. Prompt template, category explanations, all these things are easily understood. So from traditional AI to agentic AI. Traditional AI requires prompts. Even now, somebody will have to define a prompt, either explicitly programmed or implicitly given as rules based on pattern recognition prediction. Agentic AI takes action to achieve a defined outcome, often without direct human input. If the outcome is completely defined, agentic AI will take you there. Perceiving environment, reasoning, executive actions, learning from outcomes. So we are also integrating software agents to make it agentic AI. What agent can do with Excel? ChatGPT and agent. Process data in bulk, huge volumes of data. Enrich your data. Generate content. Analyze and summarize. Work with formulae, should have been formulae, I'm sorry. Work with formulae. Create, fix, or explain spreadsheet formulae using natural language. So now you see the formula is expressible in simple terms to anybody who wants to look at it. Tomorrow we will tell that Maxwell's equations are all there. Even if Maxwell's equations are governing the spreadsheet, you will simply get the result in natural language. Explain the spreadsheet formulae. They create, fix inconsistencies, it's something which we can attempt, which we worthwhile attempting. Why use the agent in GPT? E-commerce, digital marketing teams creating optimizing product descriptions, copy and SEO content at scale. You see, when we were talking about HTML to the school students, it's early 2000s, 2001, there was a huge discussion on the next advancement of markup languages called XML. What is the difference between HTML and XML? HTML is hyperlinked, but then if you want to make a survey of, let us say, the cars, various cars and prices, it is not so easy to keep on clicking, navigating, cross-checking manually. XML pages are automatically connectable. They are written in a markup language that connects all details about cars and prices, if that was your search engine query, and it'll get optimized. This is the brand of a car. This is what is it costing. Market research analysts conducting competitive analysis or understanding product and service offerings. Sales and customer relationship management teams managing lead generation, sales outreach, and CRM enrichment or segmentation. Consumer insights specialists cleaning and analyzing survey responses or customer feedback. So, as we saw the progress from LandPar to VisiCalc to SuperCalc to Lotus 123 to Excel, and definitely the ingenious features included in Microsoft Excel. But then it draws heavily on those 2 decades of strong lessons we learned, builds it, integrates into a wide range of office automation suites. And now you can have a plugin of a ChatGPT. It'll still be there, something like a button. Agents, both of them can come together. Translating your customer tickets with GPT in Excel. With the Translate Bulk tool in GPT for Excel, you benefit from a built-in ChatGPT translator integrated with Excel's interface. Not only can you have ChatGPT translate the content of any column in your Excel worksheet, but you can also attach translation instructions. In addition to the formula, that cell will now have a translation instruction. Provide a glossary of terms, handle a very large number of rows at once, access advanced parameters, get consistent translations. So imagine it's a multinational exercise happening online. It is. And that exercise, let's say Amazon, and it keeps on accumulating data at neck-breaking speed. Or today you talk about Swiggy, accumulates data at a neck-breaking speed. All that will be converted nicely into a spreadsheet. You can have translating instructions. You will have something like this happening automatically. You see, in the middle, we have different multilingual translations. They're all happening. So-and-so has created 3 cells. Translation instructions are now includable along with the cell. It's a spreadsheet. If you click on it, depending on the user login credentials, you'll see the translations. Translated ticket in English. Original ticket has multiple languages. You can translate it into English. My package has not arrived. Couriers, speed post. It's huge data. Huge data, tracking data, real-time tracking. The way we are doing, it is offering a great scope that multiple agents can work across multiple locations, decentralized, completely distributed, but you can all get them together please have a ChatGPT plugin and you would understand what is happening. Millions of such records will happen in a Ziffy, and you can have a translator included. Categorizing companies by industry and product. With the classify bulk tool, you can classify the content of any column in your Excel worksheet into preset categories. It will sort, it will sift. You can run this tool on your company database to categorize companies by industry and by product. You can also use it effectively to classify products by type, color, or supplier, for example. Can happen like that. Categorization is a very powerful tool. Very quickly, you can have Brightpath software, a quick description, develops innovative accounting and finance management software. The ChatGPT tool, categorization tool, will simply tell Brightpath software is for software development. The predefined categories of your company. Immediately, in a flash, you'll get the predefined categories. Tech trend robotics. Robotics is the category. Farm fresh organics. It automatically finds out the category is agriculture. So you see, it is a very good tool to classify. Again, millions of records. The data is getting accumulated. The value of that data is to segregate, to categorize. Categorize, abstraction. These two are very powerful tools in data analytics. So a couple of days back, there was a nice lecture by ACM, Association of Computing Machineries, and it is titled, I was going through that in preparation of this, and I got some good ideas. So 1 minute, ACM. Oh no, I have lost track of it. Just give me 1 minute. Any questions? You can please think of it in the in this few minutes. Recording is available. How to extract meaningful insights from data available. So this is where we have been talking about the importance of collecting zillions of records. And in a flash, we have to make sure that they are all analyzed. Just a plugin in a typical organization's Excel management, we can do everything. We can do every work possible, and it was visible. It was easily understandable. Extracting meaningful. So this was a lecture on extracting meaningful. Yes. Oh. I'll be able to locate that ACM lecture. Okay. I'll get the details at the earliest. I'll post it out. So let's get on with this task. You see, this is what is zillions of records. Every organization has matured into using the office automation tools, Microsoft Office, well connected, PPT is connected, a host of tools come. But one ChatGPT plugin or using it on the web makes a whole lot of a difference, because it's just connecting you to the world, putting it in the way you want it, connecting it to what you already have as your business intelligence. It's something which is remarkable. Extracting key information from customer feedback, sorting customer feedback can be time consuming, especially when it comes in different formats. However, GPT NER capability, named entity recognition, you can now have GPT extract entities. So GPT will give you more functions. on each cell or a group of cells, a bulk of cells, translation, categorization, analyzing customer feedback. All of us are getting the same thing. Once we have used a service, next minute a mail comes. The Please give your feedback. One link. Purchase something in a departmental store. Your feedback, please. Absolutely important to note that we're accumulating feedback, accumulating data. Who will analyze? That's something which we have to really look into. Now you see how it is customer feedback. Really allow the quick change battery pack. It lasts all day, charges quickly. What is the essence of it? The product about which the customer is giving the feedback is like this. There's no point in having 100 products and getting products feedback from all customers of the 100 products dumped into the same same database engine or same spreadsheet to look up. How do we analyze it? How many online customers are there? It's a mind-boggling data that we are collecting, not entirely structured. So you see how much of scope is there. I'm giving you only few examples in this lecture. Performing sentiment analysis. Is the comment positive? Is the customer feedback? Sentiment analysis is being done separately. But then can automatically do it for us. Let's build a categorized bulk tool, boost it with GPT sentiment analysis capabilities. Connect it. Automatically, you'll get one more column flashed. Say the customer feedback is like this. The column flashed is sentiment. Positive, negative, positive, neutral, all in a jiffy. It happens very quickly. Building a database of sales leads, 100 to 500 employees, technology. How do you scent the market? What are all the sales leads? The sales teams are running around, they are putting in a lot of feedback. The footfalls when a product is launched, a mobile phone launch. This was something which I was actively working on. It was just there on a given evening, multiple locations it was launched. Data gets collected, but at that time, we didn't have a sophisticated ChatGPT. We were trying to run programs of the data captured. The data captured must be accessible in different formats. All these things were real challenges at that time. Now, ChatGPT has made it all a little more easy. Creating talking points. What do you want to talk about? If you go to Chicago, how is your customer base? What are the talking points? Copywriting services will do that. San Francisco, what will be the talking points to go and talk to? It gives you all those facilities. So you see something like these are all exceedingly important. Creating talking points based on area wise, lot of data is there. Swiggy collects data, Amazon collects data, online shopping, online services. Data keeps on getting accumulated. Banks, banking industry, each time a research conference happens, they talk about data analysis specific to certain angle. So it is now something which we can do, millions of records analyzed in a Ziffy. So I took examples of translating tool, which is very, very important. Translation tool is very important. Then GPT based translation, categorization based on the industry, categorization based on the product. Multiple products are there. Categorization based on that. Sentiment on a feedback, customer feedback, talking points. So I could illustrate about half a dozen wonderful examples that can be done on a mind-boggling quantity of data that's collected, reasonably structured, well integrated into what we have been normally doing using Excel. That itself is a very powerful tool. Excel in itself is a very powerful tool. We should not underestimate. Now with ChatGPT and agentic AI, it has assumed many dimensions. multiple dimensions. So creating talking points based on the theme that we are looking at. Question 1. You can do this cost to company. Give me a 20 rows sample data in table format where first column must be employees ID, then second column must be Indian employee name, third column must be gender, fourth column must be birth date of employee, fifth column must be employee annual CTC. CTC is cost to company. It's easy to get it. Give me a 20 rows sample data in table format, where first column must be employee ID. As we speak, this table will come. Using a voice input, some letters here and there are missing, but it doesn't matter. Question 2. Thanks, table of sample data. Now I have copied and pasted this data into my Excel sheet, where employee ID appears in A column. Now I want to make some calculation first. First of all, tell me what do I change currency format of employees annual CTC from dollar format to Indian rupees. Format change. Above steps, but problem is that employee CTC has comma inside the number and dollar sign is also not from the currency format. It's a character over there. So I want to remove comma. You can just talk it over into the microphone and you see the spreadsheet changing accordingly. You'll see that happening. You want to remove comma from the CTC and also remove the dollar sign. So tell me how to remove these two things from the employee CTC. Great guidance so far. Now I have got the new values. I have got the new values in F column. I wanted to paste these values into E column, but there is a formula inside F column, so that's why I'm not able to paste it properly. To tell me that how to paste it so that I should get F column values in place of E column. Change the format. Now all this is just a narrative. Nothing else is happening. So what we are doing is very simple. It's just a narrative into, let's say, something like a dictaphone kind of a facility. Give me 20 rows sample data in table format, where first column must be employee ID, then second column must be Indian employee name, third column must be gender, fourth column must be birth date, a fictitious problem. Fifth column must be employee annual CTC, cost to company. Okay, thanks for the table of the sample data. Now I have copied and pasted this data into my Excel sheet, where employee ID appears in A column. And now I want to make some calculation. First of all, tell me what do I do? Change currency format for employee. Follow again, the English is not necessarily so well structured. It is just narrated into something like a dictaphone with all the noisy communication channels. Currency formats a character over there. Now please remember all those examples that I have cited earlier are all collecting data like this. Online data is collecting, feedback is getting collected, customer locations, customer data, so much is there. It's always easy to understand that we can do those exercises. Remove the dollar signs. So tell me how to remove these two things from dollar to Indian rupee. Then we have E column, F column. I didn't like the column ordering, not able to paste it properly. So get F column values in place of E column. It does it. Yes, I did it, but there's a green mark on the cell E column. It shows several options like number sorted. Now all this is happening because there's a ChatGPT plugin. Ignore error. What should I select from these options? Plugin is possible. Just have it plugged into Excel and we can simply talk it over on voice. A very fictitious example. Very quickly, all that data will come. We can paste it and you can have multiple windows, much like the Apple Macintosh. Cutting and pasting is easy. Very rapid advances. ChatGPT prompts, you don't even have to have so many questions. Q1, Q2, Q3, Q4, Q5. ChatGPT prompts for Excel. How many? 320 prompts. AI-driven solutions to master Excel, automate workflows, and boost productivity. It just happens. Very recently released book by Jaideep Parashar. He's an author, is a keynote speaker, and a very good researcher. So it's a very good book. 320 working prompts, well engineered. You don't have to be verbose at all like this. Question 1, question 2, question 3, question 4. But you see, in a Ziffy, I was able to come out with a spreadsheet, well constructed spreadsheet, alter it, change the dollar to rupees, commas, formatting the spreadsheet. Everything is done. Now you add a bit of programming, Visual Basic. It does all that automatically. Format converter, format beautifier, Excel sheet beautifier. It will do automatically. Piped into one and will come out. So 320 prompts, AI-driven solutions to master Excel. I still remember with many fond recollections the launch of EX in 1991 by Tata Consultancy Services. Mr. Kohli himself was there. Mr. Kohli is not there now. EX in 1991 was done in Bombay. The world's friendliest business accounting software. Everything else is complex. The same screens you get emulatable using Visual Basic adapters much more easily. VB adapters will give it much. Technology has advanced. The display devices have advanced. The connectivity has rapidly increased. But that's a fact. It's the world's friendliest business accounting software at that time in 1991. Everything else is complex. That is how the two letters EX came. See, these screens are very common. As I said, you can adjust them, put one by the side of another, and it's easy to work around. All that we have to have is have a plugin. Tally, the power of simplicity. That was the slogan for Tally. Tally was introduced for school students somewhere towards the later part of 2000s. School students were taught Tally. I was very actively working on the computer science textbooks for the government of Tamil Nadu. And this was also coming along, the commerce and the accounting, the other stream. They called me into a committee, and we have to specifically focus on Tally, introducing Tally. Now Tally is connected well to ERP 9. It's easy. It's something which is very easy, but then you don't have to do any manual intervention. Most of the manual intervention will vanish the moment you get what is called the ChatGPT plugin or use it in the web. But then there is no point in using the ChatGPT unless we are talking about volumes, sales leads, complex analysis. It should be a very complex idea to work along. Otherwise, there is something which is very difficult. January 13th, it was a talk that I attended, which I was mentioning. It was a talk on January 13th, and I found it very useful. Thanks to Kamna, because she gave me the topic much earlier. How to extract meaningful insights from data. So this was a lecture done for ACM by Angelica Loduca. She's a researcher at the Institute of Informatics and Telematics of National Research Council, Italy. So UX researcher was the moderator. Victor Yoko was a UX researcher. It was a very good talk, very illuminating talk. The challenges are many because we are now no more talking only about numerics, quantitative. Everything is there. Voice is there, snippets are there, mails are there, messages are there. We are putting together everything, just a plugin. It need not be centered on this machine. It will be collatable, presented on this machine. It's a very powerful combination which, when used imaginatively, will derive such meaningful insights in a jiffy. It's a nice talk on January 13th, few days back, meaningful insights from data. So you see, what are all the data that we are collecting in what formats? The data is no more quantitative, not necessarily. And the volumes, millions of records are getting created by the time I change from one slide to another slide of this presentation. Zillions. They're just getting created. So many online transactions are happening. And we need to somehow make our business logic built into Excel connect to the outside world. So you see how many things are possible. We can talk about talking points based on a geographic region. We can talk about sales, how the sales team is getting the leads, how do they anticipate? Interests are being expressed. Some people were staring on at that time, why is this fellow staring at the at this product launch? Is he likely to buy? Video analytics, so many things are happening. It's a good idea to have this topic in this particular lecture. It's not necessarily quantitative, but many things are happening. Data leads, survey results, sentiment analysis, and we talk about customer feedback. Every time you are availing a service, whether it's a Ola or whatever, customer feedback. Please give it. We do give it. We want to encourage them. They are all running only looking at the mobile technologies and nothing else. And they are just glued onto the mobile screen. It comes automatically. Nothing else is observed by them. And so we have to give them feedback. We have to give them support in their existing organizations. The best of the thing that I liked was the translation, so I put it at the first. Selectively, some cells will have a request for translations. Supporting multilingualism, we get multilingual data, so that's how it is. All these are happening now. So we need to understand very quickly that we will have to make sure agentic AI, process data in bulk, enrich your data, generate content. It writes an essay on what you have done, work with formulae. So what is it that we are coming back? The question that Prakash was asking me, my earlier lecturer, uh, what is it that we are for? Why do we need people to do when everything is done automatically? So that's the ingenuity that we have to think of. Please ponder. I'm not concluding anything. These are all possibilities. Again, I'm not attesting to the veracity of this exercise, but I'm telling the feasibility of this exercise. It is feasible. A simple language, transliterated in a dictaphone-like facility, 5 questions, simple 5 questions, and it does wonders. It changes everything. A very rapid advances. ChatGPT prompts, 320 prompts collected together exclusively for Excel. Well engineered. So that's the power that we are talking today in the last 90 minutes. 90 minutes is not just enough. Who will give the meaning is the question. The meaning is by us. How to extract meaningful insights from all these wonderful exercises is still a challenge. Thank you. I suppose it's 9:30.
Yes, sir, it is. Thank you so much. You're right on the clock, if I may say so. And thank you so much for that session. Very, very informative as usual. And it is a privilege for us to attend your classes without having to be in the physical classroom and learn from you. So thank you so much for that. And I'll request all the faculty members to join again at the same time tomorrow, 6 o'clock. And sir, I'll call you tomorrow to discuss how we can take Future Skills Prime to this to the new university which you have joined as well.
Sure. We'll
Yes.
discuss.
Yes. Thank you so much. Thank you,
Thank
everyone.
you. Thank
Thank
you.
you.
Can I leave now?
Sir, if you can share your presentation with me,
Yes,
I'll share
I'll
it
do
with.
that. I'll
Yes.
send it right away.
Thank you, sir. Thank you.
Thank you.